So we're looking at the 2019 free response question, and this is question number 1. And in it, you see you have these two functions. And the first one is e at t, and that is the rate. So you want to think about that as a derivative because it's a rate, and that's the rate at which the fish are entering the lake. And then we have another rate, which is the rate at which the fish are leaving the lake. Now, you notice up above here, I have this typed. I would type these in my calculator as y sub 1 and y sub 2 so that I have them for use later on in the problem. But I'm not going to write that on my AP question response that I would upload because the AP board hates it when you have calculator speak. So the question is, how many fish enter? So we're only looking at entering the lake, and we have a 5-hour period from t equals 0 to t equals 5. So we are going to, this is the rate. So if we want the number from the rate, this is fish per hour, and we want the actual fish. So what you're going to do is find the area under the curve to get the actual number of fish, which is the integral. So I'm going to do the integral, putting my upper and lower boundary on. And now I could write out this function, but in all reality, it's been defined. So I can just put the e at t and then make sure you always put the dt. You want to make sure you have proper notation. Now, on my calculator, which I would not write, I already have that as y sub 1. So I would integrate y sub 1 at x from response to x from 0 to 5. And again, I would not write this down. This would not be written. The calculator board would not approve of that. So now I'm going to get my answer. So my answer is approximately 153.457. And now it's important to go back to the question and see what the question was asking. It was asking for the whole number. So I'm going to say 153 fish enter the lake. And here's another key point. Include the time period from t equals 0 midnight to t equals 5 a.m. So you want to put the answer, the label, and the interval at which that answer is referring to. Continuing where we left off, we are going to now look at part B, and it says, what is the average? So it's important that you remember how to find the average, and the average value with integrals is equal to 1 over b minus a, so upper boundary minus lower boundary, times the integral from 0 to 5 of 4 plus 2 to the 0.1 t squared dt. But in all reality, you could write 1 over 5 minus 0, the integral from 0 to 5, and put the L at t dt. You wouldn't need to write out the actual formula. And so then using your calculator, you're going to find that that is 6.059. And so that is, again, using the words, the average number of fish that leave the lake from midnight to 5 a.m. is 6.059 fish per hour. All right, so continuing on with part C, at what time from 0 to 8 is the greatest number of fish in the lake? So the key is the greatest number, so you're thinking absolute max. And again, absolute max occurs at the endpoints or at a critical number. So let's just start off with making sure we understand that the number of fish in the lake and I apologize for my handwriting here. The number of fish in the lake is equal to the integral from 0 to 8 of e at t, the rate at which they're entering, integrated, minus the integral from 0 to 8 of L at t dt. That's at over the 8 period time at 8. That is how many fish are in the lake. So if we want to max or min, we're going to take the derivative of that. So the derivative of the integral is just going to be e at t minus L at t. That's going to be the derivative. So I'm going to set that equal to 0, and I'm going to use my calculator to solve that. So again, I'm setting my derivative equal to 0, and again, it's the derivative of this, which would be the answer to the integral, which is just the rates that we were given in the original problem. So when I solve that on my graphing calculator, I get 6.20356. So now an absolute max or min occurs at either an endpoint or at a derivative. So my endpoints are 0 and 8. And then I have this critical number at 6.20356. So if I put a 0 in, I'm going to get out 0. If I put in 6, I'm going to have the integral from 0 to 6.203 of e at t minus L at t dt, which is approximately 135.0149. And then I'm going to take the integral from 0 to 8 of e at t minus L at t. Again, evaluating the endpoints and the critical numbers in the original function, which is the number of fish in the lake, which is the integral here, and I get 80.919. So the maximum value, the biggest one, is going to be the 135. So the greatest number of fish in the lake, and again, make sure you include your interval. So we have from 0 is less than or equal to t is less than or equal to 8 is 6.203, and then make sure you label it. Is the rate of change in the number of fish, so we're looking at D, in the lake increasing or decreasing? Now remember, increasing or decreasing is based on the sign, positive or negative, of the derivative. So is the rate of change in the number of fish increasing or decreasing? So the rate of change is the overall function. So the rate of change is E at t minus L at t. That's the rate of change. So if we want to know if that's increasing or decreasing, we're going to need to know E prime at 5 minus L prime at 5, and then determine if that is greater than 0 or less than 0 to determine if it is increasing or decreasing. Now, I would not write this, but this is what I did on my calculator. I took the derivative ddx, and I have it stored in y sub 1 at x. And I have that minus y sub 2 at x because I already had that stored. And I'm going to evaluate that at x. So I'm finding the derivative. And then I'm going to put this line. This tells me to evaluate it at x equals 5. So this, again, is calculator speak, which this would not be written on the AP exam. So do not write this. So now, when I do that, I am getting E prime at 5 minus L prime at 5, and I'm getting negative 10.722. And so that is less than 0. So since it is less than 0, I'm going to put, since E prime at 5 minus L prime at 5 is less than 0, the rate of change of the fish in the lake is decreasing. So that is what I would do. Again, not including the calculator speak on the AP exam. Now, they did